Good morning, everyone. How are you guys doing today? The weather is so nice. So, as you requested, the exam will not be today. It will be day after tomorrow, which is 10. It's the 10. It's 12, March 12. And let me remind you again what will be in the exam. Question from 5.1. 5.1, mostly the exponent rules. So you should know all the exponent rules. How many points will be in the exponent rules? Do you remember? In the exam? How many points? 35. 35. Exponent rules. 35 is just basic rules. So one page, 35 questions. All you have to do is remember your rules and then write down just one line. Not even line, like one number. Okay. So 5.1, mostly those. For example, what is -1/4 to the power 0? 1. See, I'm going to give you exactly like this one, question 1 or 2, and then all you have to do is write down the answer. 1. And what's the answer for B? When you have multiple powers, what do? Multiply them. So you're going to write x to the how much? 63. That's all you have to do for 35 rules. And for 3 and 4, this will be inside 10.2. So similar question. So 3 and 4, they are like 10.2. So in 10.2, I'm going to ask a few. I didn't make the exam yet, but probably at least 5 of them. What is anything to the power 0? 1. Anything that is not 0 to the power 0 is 1. Do you remember what is 0 to the power 0? Good, undefined, doesn't exist. That's why any base to the power 0 that is not 0 on the base, the answer is always 1. So anything not 0 to the power 0 is always 1. So I'm going to give a few of them, like at least 4 of them. Positive base, negative base, 0 base, fraction base. What will be the answer for all of these besides 0 to the power 0? 1. So see? Now for 10.2, there are so many questions, so many same type, but so many questions. But you have to be careful about having a negative in the front and having a negative inside the parentheses. Be mindful about that. And definitely one of these from 21, 22, 23. And then all the rest are very similar, but let me distinguish them. These have negative powers. So definitely one with the negative powers. And what else? So this is also negative power. This is a negative base with add denominator. So what happens to the negative base at denominator? What happens negative base with even denominator? And what happens when there is no parentheses next to your parentheses on your negative sign? So these are few types you have to be careful about. Yeah. So at least how many? One of these, two of these, one of these, these 3 have negative powers. So at least one from these 3 negative powers. So 2, 3, 2, 3, 4, 5. 2, 3, 4, 5, 6. I can see at least 6 of them here. From 10.2, sorry, 5.2, there is one question. Addition, subtraction. Be very careful when you subtract. What happens when you subtract any polynomial or anything? The sign changes. So first you have to distribute the negative. So this will turn into positive and this will turn into positive, and then you combine them. For addition, we don't have to do anything. We don't worry about anything, but for subtraction, always change the sign. Now for multiplication, here three types of multiplication. One is this type, where you simply multiply two polynomials. So one of these. And then we have second type, where we have the same thing, same base with multiple powers, square power. And then we have difference of perfect squares. So not sure, should I give you two of them or should I give you one of them? So it could be one or two. Okay. But this is definitely one. From 6.2, 6.1 to 4.5, they all are factoring. So for factoring, you're going to have two terms with GCF with difference of perfect square, and then GCF plus difference of perfect squares for two terms. Now for four terms, there's only one question, a combination of everything. GCF plus grouping, and maybe, not sure, difference of perfect squares in the grouping. But definitely one from four terms. And then for three terms, there are so many choices we have. Three terms. One is GCF. The second is GCF plus direct factoring. Right, nicely. Come on. Direct factoring. Then we have probably GCF plus AC method. So at least three types. Now, if I have space, I will give you some direct factoring without GCF. It means question like this. All you have to do is factor directly, factor directly, factor directly. Or GCF and factoring is like this one. You have a GCF and then you have to use factoring AC method. And then all of these are two terms. Now in the two terms, I forgot about one more thing. GCF at difference of squares, and then we have double difference of squares. Double difference of squares. And that's it. So factoring, mostly factoring, and one page, all these rules. But I'm not going to ask you the rule themselves. I'm going to give you some question, and then just all you have to do is apply the rule to give me the final result. For example, if I give you 2/3 to the negative 3 power, what do you get from here? Positive what? We have a fraction inside a negative power. How can you convert the negative power into positive power? Yeah, but you already have a fraction, so it will be easier. Flip the fraction. So you get 3/2, and then the negative 3 turned into positive 3. But you cannot stop here because you can distribute your 3. So if you distribute the 3, what do you get on the numerator? 3 times 3 times 3, 27. And on the denominator, 2 times 2 times 2, 8. So that's all you have to do. You don't have to do any math, like a big math. All you have to do is apply the powering, apply the exponent rule. So this is your rule number 1, and this is your rule number 2. Rule number 1 says flip your fraction, negative will turn into positive. And rule number 2 says if you have a multiplication or division on the base, but only one power, distribute the power. For example, I can give you what is 2 cubed times 2 to the, let's say 10. What's the answer? 2 to the 13. And 13 is a big number. There is no way you can multiply 2 times 2 times 2 times 2 times 2 times 2. So for big numbers, don't do anything. Just leave it. For smaller number, like any number that is 5 or less, work with those. And if you have something bigger, for more than 5, don't do anything. Leave them alone. What else I can give you? I can give you for this one, let's say 4 squared with a cube. What's the answer? 4 to the how much? 4 to the 6. And 6 is big. 4 times 4 times 4 times 4. Don't waste your time. Keep it. For 4, 5 is also big. So for 4, we'll land up to 4. 4 square is 16. 4 cube is 64. 4 to the 4 is 256 or something, right? You start with 2. You see what is 2 to the power. What is t to the power? One of them definitely will be from 2 to 5, 2 to 7. The answer will be. For example, see here you see 243, and we have a denominator 5. That means you're looking for same number multiply 5 times. The answer is 243. So 5 times is a big number. So you start with number 2. You multiply 2 5 times. 2 is an even number, so it doesn't matter how many times you multiply, the answer always will be even. But 243 is an odd number. So 2 not going to work, then you go to 3 and then see if 3 works. If 3 doesn't work, 4 definitely not going to work because 4 is an even number, but this is an odd number. So you go to 5. And in this class, it's everything less than 7. The answer is always less than 7. And for 7, they'll give you like probably highest degree 3. So 7 times 7 is 49. And then you multiply 7 one more time, and then you get whatever that is. 256. We are looking for one number 4 times. 1, 2, 3, 4. So since this is an even number, most likely our answer will be even number. So start with 2. What is 2 to the 4? 2 times 2 times 2 times 2? 16. So the answer is not 16. For 3, the answer will be add. But this is an even number, so you're going to skip 3. Then you go to 4. 4 times 4 is 16. 16 times 4 is 64. 64 times 4 is 256. That's how you find. You start with 2 and then go up to 7. Okay, so now from any of these, do you want me to go over any question? Do you want to refresh your memory with anything? Number 18. 256. Okay. So let me do it here. We have 1 over 256 whole thing to the power 3/4. Now we are going to apply the power rule. First power rule says if you have a division with the same power, what do? We distribute. So x to the n, y to the n. We apply this rule and we get 1 to the power 3/4 and then 256 to the power 3/4. And then we go to the second rule. On the numerator, we have 1. So rule number 1, 1 to the anything, positive, negative, fraction, whole number, 0. What is 1 to the anything? 1. So our numerator turns into just 1, and we work with the denominator. On the denominator, we have 4 on the fraction. So we want to rewrite our base some number to the power 4, and we keep our 3/4 outside. So what number, when you multiply 4 times, the answer is 256? 4. So we rewrite the base based on the denominator, always based on the denominator, never based on the numerator. So base, denominator. Why do we care about the denominator? What is our goal to rewrite? Cancel. We don't like denominator. So to cancel the denominator, we have a whole number power on our base. So from there, it's just algebra. We have 1 on the numerator. And after the cancellation, what do you on the denominator? What is left? 4 and then 3 power. And I multiply 4 times 4 times 4. 64.
And we put 1 over 64 question.
We have 1 on the numerator and 4q on the denominator. So it's 1 over. Let's do an example. Let's do 15 and 16. -4 3/2. 15. -4 3/2. And -4 parentheses 3/2. When you don't have a parenthesis, what it means? It's a coefficient or it's a multiplication. So negative times 4 to the power 3/2. So this negative doesn't affect us because it's a multiplication. So we keep this and we rewrite our 4 using what number? 2 square. 4 is 2 square, so we cancel the 2's. We have a negative and then 2q. What is negative 2q? Cube, 3, 8. So our answer does exist. It's a real number, -8. On the other hand, for this scenario, what is our base? -4. And our power, the denominator, is even. So can you multiply same thing twice and the answer will be -4? So what's the answer? Undefined or DNA. See here, we multiply same number twice, we got 4. It exists, we found that. But here it doesn't exist. If you know them, sure, no problem. But we are not learning it yet. So for now, if you write DNA, it's not a good idea. That's a bad idea. So that's the difference between having a parenthesis and not having a parenthesis with a negative sign. Then we have this type of question where we have multiple powers, multiple numbers, everything. So definitely one of these. 23 is too easy, so it will not be in the exam. You'll see either 21 or 22, one of these type. And they both are same. Do you remember what we do first? What do you do? You can do that, but that also has a bad side. I would recommend you to distribute first. Because what if you have a negative inside the negative? Then you may get lost. For example, what if I give you 2x to the negative 2 with the negative 2 on the denominator? So do the flipping later, fast, distribute. So we distribute the numerator 2 on the numerator, denominator negative 2 on the denominator. So numerator we have 6x to the negative 3. On the denominator we have 2x squared. Numerator gets 2 power because we have 2 on the top. Denominator gets negative 2 power because our power on the denominator is negative 2. So step 1, distribute. Then step 2, exponent rules. We have multiple exponents for same base. What do you do? Multiply. And we have the same scenario twice. One on the numerator, one on the denominator. So keep your 6 square. If you want, you can put 36, no problem. Or you can keep your 6 square. And then what is negative 3 times 2? Negative 6. 2 with the negative 2 power and x with the negative 4 power. So we applied that after distributing, we applied the exponent rules and now switch position. Swap every negative exponent. Swap position, I should say. Swap position for every negative exponent. So the 6 squared, does 6 have a negative exponent? So we keep it. Does x to the negative 6 has a negative exponent? So we need to swap it on the denominator. Then we go to the denominator. Does 2 have a negative exponent on the denominator? So we need to bring up and becomes positive. And then on the denominator, does x have a negative 4 power? So I need to bring it up to make it positive. So for every negative exponent, if it's positive, don't swap anything, don't do anything. Keep the position same. But if you have a negative exponent, swap them around. And lastly, simplify. So we have another exponent rule, the division rule. What do we do in division with what do we do the powers in division? Subtract. What from what? Highest power, you keep the position. So which one is higher, 4 or 6? So keep your 6 position. And then you're going to subtract how much? 4, because numerator is 4. So we simplified this. And now we have 6 squared. How much is 6 squared? And then we have 2 squared, 4. And then you multiply manually. I don't remember, it's probably 144 or something, right? 144, and the denominator is x squared. If you do 4 minus 6, you're going to have negative exponent, but it cannot have a negative exponent in your final answer. So you have to bring it to the denominator to make it positive anyway. Well, definitely one of these you're going to see. And let me also tell you this, we never did this in class, but let's say after the distribution you get another example. Let's say you have 36, and then let's say you have 9, and then you have, let's say, x to the -5, x to the -5. Actually, 5 never going to happen. Let's say 6. Then you don't even have to swap, because you see the same power, same variable, same everything. You can simply cancel them because they are exactly same thing. If you have exactly same thing, just cancel them. But if they are not exact same, then swap them and then simplify them. And also you can combine these two. You can divide them. What is 36 divided by 9? 9 goes to 36 how many times? 4 times. So the answer will be 4 without any variable. So you don't, not always you're going to have a variable and a number. Sometimes you may have only variables, sometimes you may have only numbers. Okay. Any question? We did these two. We did this type. Now let's do something with add denominator with negative base, and then fraction denominator with negative base. Sorry, negative fraction power. So negative 64 2/3. Negative 64 to the 2/3. So here, this negative is not inside the parentheses. So it's a multiplication. As long as it's not inside the parentheses, always multiplication. So it's multiplication, and then we have 2/3 power. So how you want to rewrite your 64? With what power? 3 power. So what number when you multiply 3 times, the answer is 64? 4. So it's 4 cubed. So negative times, what happens to the 3 power and 3 denominator? Cancel. And what is left? 4 with the square. And how much is 4 with the square? 16. So this is negative 16 because negative is a multiplication. Oh, and also I forgot to tell you the difference between negative 4 square and negative 4 whole thing square. What's the difference between them? What is negative 4 and then square? How much is this? Negative and then 16. So anytime it's not in the base, not inside the parentheses, it's always multiplication. So it's negative times 16, which is simply negative 16. But how about negative 4 whole thing square? Positive 16. Because your base is negative 4, so you multiply negative 4 twice, you end up getting positive 16. So I'm going to give these two with different numbers, obviously. So these two, one of these, and the negative in the front based on the add power, and there's one more fraction. What question I have for the fraction? -16 3/4. 16 -3/4. 16 to the -3/4. So here we are going to use two rules. One is when you have x to the negative power, what do you get? 1 over the entire x to the positive n. And then we are going to use the rule we did so far, rewriting the base to cancel the denominator. So keep the fraction for the end, otherwise you will forget it's a fraction. So keep your negative 3/4 and rewrite your 16. What we are looking for? One number, how many times? So can you find same number 4 times, turn into 4, turn into 16, sorry, 2. So we have 2 to the 4. And then what happens to the 4? Cancel out. So we have 2 inside and negative 3 outside power. And now we use this rule. What is 2 to the negative 3? 1 over 2 to the positive 3. And then we go to 2 times 2 times 2. What is 2 times 2 times 2? 8. So it's a fraction 8, which is 1 over 8. So anytime you have a negative power, your answer has to be fraction if your whole number inside the base. The same scenario, let me erase this. The same scenario, but what if we have a negative sign inside the parentheses? Now what will be the answer? Why? Because you're looking for same number 4 times, right? So can you find same number 4 times turn into negative 16? Impossible. So all you have to do is doesn't exist. That's why I would recommend every time actually do this step. Based on the denominator, write down how many times you want the same number and what you're looking for. So base is 16, we want to get 16 by writing same number 4 times. It's possible, so we go to the math. Same thing here, our base is now negative 16. So we are looking for something, if you multiply denominator many times, we get our base. And you automatically know that 4 times can never give us a negative. So it doesn't happen. But this is actually a good step to figure out whether you have an answer or you don't have an answer. Any question? Yeah. These are possible scenarios you'll see in the exam. And then you have multiplication. For addition, subtraction, the main concept, the main scary part is subtraction. Anytime you subtract anything, make sure to distribute the sign. If you have a plus sign, it will turn into minus. If you have a minus sign, it will turn into a plus. So first do the distribution of the negative and then combine like terms. Personally, I like to write them down one after another one below another one. So we have 2x cubed, 2x squared, another 2x squared, and then this becomes 4x squared. So add all of these because they all have plus sign. And then we have 7x plus the 8x, and then there is no more x, so find how much is that. For number, we have +1, and then when you distribute, you get +17. So do the math, write them down, and then you have your final answer. So instead of going horizontally, if you write them vertically, you make less mistake. But it's up to you, whatever is easier for you. For multiplication, you take one number from one polynomial and multiply everything. So either you have your box method, or you can simply do manually one by one. You take your 4x and multiply the entire polynomial, the second one. So 4x times 6x squared minus 5x plus 2. And then you take your second term and then you multiply the entire polynomial. So second term is -3. So we have -3 times 6x squared minus 5x plus 2. So if you break it down this way, then you can see that all you have to do is now distribute each one of them and then combine like terms. Or if you find your box method is easier, go ahead and use the box method. So definitely one of these, huh? So when you multiply numbers with the numbers, and for variables, you add the powers. So we use another power rule. If you have x to the m and x to the n, we add the powers. So we are going to use this exponent rule when you multiply the bases. 24x third. And then the next one will be minus 20x squared. And then the next one will be plus 8x. And then when you receive the second one, we get -3 times 6, which is -18x squared. So -18x squared. We have x to the square power. Why we have square? It's a 2. And then -3 times -5x gives us positive 15x. So write this down below your another x. And lastly, -3 times +2 gives you -6. And then we have only these 4 like terms. So combine them 2 by 2 and you get your final answer. So this is normal multiplication. Now in 31 and 32, you can do the same thing, but you don't have to. To save you time, you observe that we have the same two bases. We have x and 1, x and 1. So in the first one, we have the same x, and on the second, we have the same 1. The only difference is that they are middle sign. One of them is positive, one of them is negative. So what do you call them? Do you remember? Difference of perfect squares. So we have two conjugates. At any time you multiply two conjugates, what do you get? The first thing square and always minus the second thing square. So that's all you have to do. The first one square minus the second one square. In other words, you get x squared minus 1. If you do the distribution, you're going to get the same result, but distribution will take you longer. So for the next one, we have 4x, 4x, and we have 3 and 3. The difference is the sign. One is plus, one is minus. So what will be the answer for this one? 4x whole thing square and minus 3 square. And now here comes another exponent rules. We have more base but one power. What do we do? We distribute. So we get 4 square x square, which is 16x square. And we know it is 3 square, right? And that's it. So you can actually go from this line to this line directly if you do the math mentally. 4 square x square, so 16x square minus 3 square is 9. So that's why do not distribute, just do this. And now this one, it says multiply your base twice. So we have our base here, and our power is 2. So you're multiplying the same 6x minus 3, same thing twice. And then you can use distribution to distribute and get the answer. But you don't have to. Why not? Because we learned a rule for that. The rule says first element square plus the second element square. So first element square means 6 squared x squared. So we get 36x squared. And then we have our second element is 3. So 3 squared gives us 9. And then you take the sign and multiply twice of their product. So 2 times 6x times 3. So 36x squared plus 9. And what is 2 times 6? 2 times 6? 12. And 12 times 3? 36x. This is the answer. And since usually we write powers in decreasing order, so it will look nicer if you write this way, 36x plus 9. They both are same. Nothing is wrong with any one of these. But this one looks more nicer. So if you can remember your rules, then you don't have to use distribution. Just apply the rule. First term square plus second term square, always. And then you always add or subtract based on the sign given to you, twice their product. So definitely one of these, and then one from each or one from combined. I'll decide, I'll see, based on the space I have in my exam. Now, for 2 terms, there are so many scenarios. This is our scenario number 1. We have a GCF. So when you have a GCF, what do you do? What is the GCF between x squared and 4x? X. So you factor out your x, and then what remains? X minus 4, and you are done. So for this type of question, I usually do is, depending on how many factors we get, I put that many points. So we have 2 factors, so 2 points. If you have 3 factors, it's 3 points, 1 point for each factor. Then we have a second scenario, x squared minus 4. Now, is it a GCF? Do you see the same thing in both terms? No. So it's not GCF. Now, you see x as a square, so definitely it's a perfect. Is 4 a perfect square? So what is this scenario? Difference of perfect squares. So how do you factor difference of perfect squares? It is the square root of each quantity. What is square root of x squared? And what is square root of 4? And then what do you do with these two? X plus 2, x minus 2. And you are done. So be very careful about them, okay? They look very similar, but they are not same. They're similar, but not same. This is a GCF, but this is not a GCF. This is perfect square. So this one also 2 factors, 2 points. So how about I combine them? How about you see something like this? We have x cubed minus 4x. Now what do you see first? GCF. So what's the GCF between x cubed and 4x? So you factor out, and what do you get? -4. And now what do you see? Difference of perfect square. So that means you have to do it one more time. So what do you get from difference of perfect squares? X plus 2, x minus 2. And don't forget about your GCF. So total, how many factors you have? 3 of them. So 3 points, 1 for each. So if you miss one of them, at least you get 2 points. I already told you at the beginning of the class. Something I don't remember. I didn't make the exam yet. But definitely one page with factoring, one page with exponent rules, and then one page with whatever we did, the things, these things. So one page with these type of things with different types of scenarios, one with exponent rule, 35 questions, and one with all those factorings, plus the multiplication. Or maybe I can put the multiplication in one page and then factor in another page. This exam is just based on this. So for 2 terms, remember 3 scenarios. Only GCF, only perfect square, or maybe it's a combination. And now for 3 terms, there will be several scenarios. For example, all of these are direct factoring. All of these. How do I know? Well, because none of these has x squared a number in the front. None of the x squared has a number in the front, right? All the x squared has invisible 1. So when you don't have any number in front of square, they're direct factoring. Means from there, you can simply go and factor directly, unless you see a GCF. Anytime you see GCF, factor that out fast, and then go to the other factoring. So none of this has GCF, right? If you observe, none of them have GCF. Now, all of them are same except these 2. In this one, our order is wrong, so you just write 54 at the end instead of in the front. So you get x squared plus 15x plus 54. Do not change sign. We only change sign when you cross an equal sign. When you cross a bridge, the equal bridge. There is no equal sign here. So you're not crossing a bridge. So you cannot change the sign. And then you factor directly. 2 numbers multiply to 54, add up to 15. So when you multiply them, the answer is positive 54. When you add them, the answer is 15. What 2 numbers you can come up with? 9 and 6. Now, if you're not sure about the sign, how to decide, the bigger number always gets the middle sign, always. So which one is bigger, 9 or 6? So 9 has to be positive. Now, if 9 is positive, what sign 6 has to have so we get 15? Positive. So that's how you can decide sign easily. Pick the sign or look for the sign for the bigger one and then decide the smaller one based on the addition. So we split out our 54 into 2 pieces, 9 and 6. And now how are you going to split your x squared? X on each. X and X. And that's what we do in direct factoring. You split the first variable into 2 pieces evenly, and you split your number into 2 pieces evenly. And we are done. So based upon this, we have 4th degree, x to the 4 minus 5, x squared minus 14. So we are going to do the same thing. We are going to split our x to the 4 into 2 pieces evenly. So if you want to split 4 of them evenly, how many each supposed to get? square. So x square and x square. And now we are going to split negative 14 into two pieces. So two numbers multiply to negative 14, but add up to negative 5. 7 and 2. So 7 times 2 is 14. And then what sign 7 must get? Negative, because the middle sign is negative. Now negative 7 plus 2 going to give you negative 5. So 2 has to be minus. If you're not sure, you can check which one is true. Negative 7 plus 2 or negative 7 minus 2. Definitely this is wrong. So direct factoring, doesn't matter what power you have. Positive 2. Thank you. I said plus 2, but I wrote minus 2. Be careful in the exam. Here I didn't get penalized, but in the exam you'll get penalized for your negative. The opposite. Fine. So direct factoring is easy. That's how you decide. And then we have AC method. Now either you may have just the AC method or you may have a GCF with the AC method. Now what do you see here? What do you observe? The first thing you notice is what? 3 terms. Good. What else you observe next? GCF. So always look for GCF. Always. It could be number, it could be variable, doesn't matter, but always look for them. So what is the GCF you see in all 3 terms? X. So you factor that out. Now once you factor out your GCF, what do you get? You had Q, but you took the X out. Square minus 25X minus 2. So we had our GCF, good. And now we have an A. So anytime you have a visible A, what method you have to use? AC method. Now there are 2 types of AC method. One is the formal AC method, which I forgot to teach you in last today. I'm going to teach you after that. So, and we have the weird AC method. So do you remember the weird AC method? What do we do? Multiply A with the C and rewrite that. So we don't write A, instead we write X squared minus 25X. And then what is your A times C? 13 times negative 2 give you? Negative 26. So forget A and replace C with AC. And now you have 3 terms without any number in the front of X squared. So you can factor directly. How are you going to split your X squared? X and X. And how about the numbers? 2 numbers multiply to negative 26, but when we add, it's negative 25. 26 and 1. Now 26 has to have what sign? Negative. So negative 26 plus 1 going to give you negative 25, or minus 1 going to give you negative 25? Plus. And now it's time for A to come back. What do we do with the A? Do you remember? We ignored A in the second step, but now it's time for it to come back. We invite A again. So what do you do? A has 2 rules now. Spread, how are you going to spread? Bring it down. Bring it down to which one? X minus 26. So where are you going to write your A? In front of X or what? Nope, you forgot the rule. One of these factors is divisible by A, the other one is not. One of these numbers actually. So we found 2 numbers, 26 and 1. One of them is divisible by A. Which one is divisible by A? 26. So whichever is divisible by A, we divide that by A. And that one is not divisible by A, what do? We multiply the variable. So we multiply and divide at the same time. One of them is divisible by A, divide that. The other one is not divisible by A, no problem, multiply the variable. And you cannot forget about your GCF. So our final answer is X from the GCF, X minus 2 from your division, and 13X plus 1 from the multiplication. What's your final answer? AC method or GCF? And if you don't have a GCF, you can still do your AC method. So you rewrite 5x squared into 1x squared and negative 21 into 5 times 21. And then do the same thing again. Factor directly, but one of them is divisible and one is not. Whichever is divisible by A, divide that. Make your life simple. And whatever is not divide, multiply the variable, not the number, the variable by A. Do I have anything? For difference of perfect squares, all of these are difference of perfect squares. So you difference them. But how about this one? Is it a difference of perfect square? So it's a sum of perfect squares. So what do you write for this? Not factorable. It's a prime polynomial. So for plus, we cannot factor. We have only factors for when you have a minus between perfect squares. And then the last one is double difference of perfect squares. When you have fourth degree, you do double. And again, you always look for GCF. This one doesn't have GCF. This one has a GCF. This one doesn't have a GCF. So if you have a GCF, factor that out fast, and then you do your double distribution. Let me do this one. So is 16 a perfect square number? Is x to the 4 a perfect square number? Obviously, 4 is a perfect number. Any even number is a perfect number for a power. And is 81 a perfect square number? That means we have difference of perfect squares. So what is square root of 16? 4. And what is square root of x to the 4? X square. So here we actually use a rule, exponent rule. If you have nth root of x to the m, this means you have the power divided by the index of your root. So in our case, we have square root of x to the 4. So x to the 4 divided by your index is square. So you get x square. So square root of x to the 4 is x square. And what is square root of 81? 9. So we found our two things that we are going to use in our factors. So how are you going to factor this? 16 x to the 4 minus 81. What two factors we get? We have our two things. So we add them. 4x squared plus 9. And then what do? We subtract them. This is difference of perfect square. It is the square root of each and then add them, subtract them. This is a plus, so not factorable. But how about this one? It's more factorable. So you get square root of 4, square root of x squared, and square root of 9. What is square root of 4? So you do factors with these. You get 2x plus 3, 2x minus 3, and you still bring it down even though it's not factorable. So we have your 3 points. Now, if you give me this, I'm going to give you 1 point only. Why? Because you're missing 2 points, 2 factors. So with this, you earn only 1 point. You lose more points. So make sure anytime you see difference of perfect squares, factor it more until you cannot factor anymore. So one of these, And then for perfect square, I give you the 3 scenario: GCF, perfect square, a combination. Oh, and for degree, not for degree, 4 of them. For 4 of them, like this, anytime you have a GCF, you always factor it out fast, and then you group them into 2 groups. Okay. Grouping method. 4 times means grouping method. I always look for GCF. I wanted to go over all the rules, but since we don't have time, just review the rules by yourself. So remember, all these rules, make sure you know how to apply them, not just memorize them. Good luck.
I won't be any luck for the 31st, which is our third exam. I was wondering if there's anything to make it up if you have that kind of a class.